In this video, I'm going to show you how to do AQA A-Level Maths Paper 1 from June 2018, question 11. My name is Sunil Tanna. I'm a tutor and author. Details on the card. I'm available for one-to-one tuition both online and in person. I live in Buckinghamshire, England. Daily production of oil can be modelled using this equation. V is equal to 10 plus 100 times T over 30 all cubed minus 50 times T over 30 to the power 4, where V is the volume of oil in millions of barrels and T is the time in years since 1st of January 1980. The model is used to predict the time, capital T, when oil production will fall to zero. Show that T satisfies this equation. Well, there's two things we're going to do. First of all, we're going to say that V is 0, so we could put that into the original equation, and then we can compare the equation that we've results and the equation that we want to get, and think about how we can get from the initial equation to the final equation that we're aiming for. So if we put in capital T for T, V is 0, the equation becomes 10. What I'll do is also expand out the brackets. So first it will be plus 100 times T cubed divided by 30 cubed. 30 cubed is 27,000. And then we'll have minus 50 T to the power 4. 30 to the power 4 is 810,000. Now, a couple of things that we will notice is the equation we're aiming for. First of all, the first thing that will probably jump out at you is there's a cube root, which suggests we're going to make a T cubed term the subject and then cube root it. However, there's something else to notice, that all the terms in the original equation there's a term in the original equation that is divided by T, which we don't have in this equation. So if we were to rearrange this, at some point we're going to need to divide all the terms by T. So what I'll do is simplify the equation somewhat and also divide by T. So dividing everything by T, 0 divided by T is still 0. It becomes 10 over T, the first term. The second term simplifies to T cubed over 270, but I'm going to divide by T. So it will be 100 T cubed, the 100 cancels out, and that will be over 270. And then dividing top and bottom of the last one by 50, it will be minus, I need to put the T on the bottom here, 16,200 T, and then on the top it will be the T to the 4. Now some of these T's are going to cancel out, so it will now be 0 is equal to 10 over T plus T squared over 270 minus T cubed over 16,200. Right. So the next thing I can do is I can see now I have a T cubed term. I have the 10 over T, which looks a little bit like this. If I was to multiply 16,000 by 200 by 10, it will give me 162,000 over T. So I'm going to bring this term to the left-hand side. T cubed over 16,200 is equal to 10 over T plus T squared over 270. Multiply both sides by 16,200, which will give me T cubed is equal to 162,000 over T. And multiply this term by 162,000, so I need to do 162,000 divided by 270, which will give me 60 T squared. And now you can see I have the inside of this cube root. So finally, this gives me T is equal to the cube root of, and I'll write the terms in the same order as the final answer, 60T squared plus 162,000 over T. And that part is complete. Okay, second part of the question. Using the iterative formula, Tn plus 1 is equal to the cube root of 60Tn plus 162,000 over Tn with T0 equals to 38, find the values of T1, T2 and T3, giving your answer to 3 decimal places. So using your calculator, what you should do is type in 38 and press equals to make it the answer in memory. And then what you'll do is you'll type in the right-hand side of this formula, but wherever there's a Tn, instead you type answer. So you type cube root of 60 times answer squared plus 162,000 divided by answer. And if you do that, what you'll find is that T0, which is the one you put in, is 38. Once you've typed in that formula and press equals, that will give you T1, which to 3 decimal places is 46.963, 3 decimal places. Press equals again, it will now give you the second answer, which will give you, sorry, I think that's 44, I misread that, sorry, 44.963. And then the next one is 49.987 to 3 decimal places. And the third one, T3, will be 53.504 to 3 decimal places. And that completes part A2 of the question. Now, the next part is explain the relevance of T0 is equal to 38. Well, we know that we started from 1980, so 1980 plus 38 is 2018. So we are starting in 2018. So we are modelling from 2018. Yeah, and of course this is a 2018 paper, so this is, at the time of the exam, this was the current year at the exam time. Right. From January 1st, 1980, the daily use of oil by one technologically developing country can be modelled using this formula. V equals 4.5 times 1.063 to the power T. Use the model to show the country's use of oil and the world oil production will be equal in the year 2029. So sometime during the year 2029. So what that suggests is at the beginning of 2029, maybe one is more than the other, and at the end of 2029, so in other words, right at the start of 2030, the other one will be more than the other. So the simplest way to do that is to compare the difference. So we can for example, we could define f of t is equal to v production minus v use, right? And what we'll do is 2000 is 29, 2029 t will be equal to 49, and we can use the formula for production, which we were given on the previous page, and put that in, and we will see that V production is equal to roughly 89.89, and we'll find, and again we can use the formula here for the V usage, and the usage in that year was 89.81. So f of 49 will be a positive value. 89.89 minus 89.81, which is 0.08, which is positive. We can do the same thing for 2030. So T here will be 50. V production, again we use the formula, and if you do that you'll get 87.16, and V use in 2030 comes out to 95.47, and so F of 50 will be 87.16 minus 95.47. So that's 87.16 minus 95.47 comes out to minus 8.31, which is negative. So this tells you there is a sign change, and and f of t is continuous. So which tells you there must be a root in the interval between t is 49 and 50, which tells you they must equal during 2029. And that completes the question.